Welcome to the Science Circle and another great time with everybody. I hope you liked the presentation. Um, Part of this presentation came out of our Monday meetings together at 10 a.m. Second Life time. Um, we have a Science Circle Moon group, which we get together and we have for 3 years now, and talked about what it would be like to live on the moon. And part of living on the moon is um, getting used to the fact that we're all moonstruck. Well, I think we're going to have to pretty soon. We're looking at another mission to the moon, international mission that could start. I mean, that could go as early as a couple of weeks from now. I think it's February 5th or 6th. It'll be the first time that humans will have gone back to or gone around the moon or even gone off out of Earth's orbit um, since 1972, I believe. So that it'll be quite something. I don't see it all hyped up in the press or anything. Back in the old days, things like Apollo 8 was the first one with people around the moon. And some of those missions, particularly 8 and 11, Apollo 11, the one that actually landed on the moon, it still has, compared to the percentage of people in the world, it still has the largest television viewing of any event in history. People were interested in this stuff back then and in technology. Okay, well, anyway, we'll see this time around. Okay, so anyway, I'd like to start. What I did was I adapted some of the stuff that we've been talking about already in the moon group, and looking in particular at both the moon and the Earth and the impact of impacts. I'll show you what I mean. So does anyone remember these two movies? The one on my left is the one I like the most. Anybody watch these ones? This is in the 90s. You have to have been a certain age to have seen this. Oh, yeah. In fact, actually, I watched the one on the left just the other week because it's cool. It's the one on the left. Okay, because they're both, now the interesting thing is they both kind of have this idea that, oh my goodness, there's a world-ending event. Let's see if we can prevent it. Get in their little spaceships or send rockets up there and blow them up or something. Well, exactly, the Irwin Allen movies. In other words, there's kind of a genre, because you got the towering inferno. In other words, you got the one, and even before that, there were the earthquake movies, and then there were the fire movies, and then there were the asteroid movies, and before that there was the alien movies, and everybody loves I guess a good disaster, because the idea is where people all come together, and they don't really believe and even the satire one recently about Don't Look Up has a world-ending asteroid event in it. And so, yeah, Poseidon Adventure even earlier. Yeah, I thought Don't Look Up was correct. So Poseidon Adventure, yeah, even before that. People love those sorts of movies. Okay. But because the whole idea is that there's people that, well, yeah, unfortunately. Bug. Yeah, that one was definitely now it was a little stretch on the science fiction part, but that was interesting too. I like that for all of the wizardry in it, so to speak. Just you have to suspend your belief as far as the science fiction stuff. But the idea is that people all come together and they try to prevent things, and there's heroes that you don't think are going to be heroes, and all of that too. Okay, so let's go ahead and take a look at the science of impacts. Okay. So you are here in other words, when we look up in space, why did I choose this? Okay, so when you look up in space, it's full of stuff. We only see a few thousand, our meager little instruments called eyes are fine for down here on Earth, but when you look up there, you only see a few thousand of the brightest objects in the sky. There's obviously billions and billions of objects in the sky that, and even more that you can't see. Oh, 6,000? Yeah, depending on, well, maybe 3,000 in your field of view on the hemisphere. And then depending on how dark it is, if you're in a city, you maybe see the moon. It's about it, billions and billions. Well, I actually met Carl Sagan once. I'm old enough, back in the early 70s. Yeah, you've only counted. Thanks, Nero. That's what I was saying. We get some humor here. Okay. So anyway, even yeah, that's it. Okay, so even in this area, must have been because there's trees or something in the way. Okay, so even in this area, what I mean in our sun, it's not just empty sky out there. We often look and we go, "Oh, that's pretty." It's a very black sky. There's not much there, but actually, it's full of stuff. The full of snow. Well, it's full of gaseous material and tiny little things we can't see. All those little red dots, by the way, are red dwarfs, and a lot of them are just don't put out enough light for us to see them with unaided eyes. Um, but they're the most common, and they're also probably the ones with the most planets that would be Earth-like or habitable in any case. And so, even in our own solar system, it's not just empty of stuff. There are tiny little objects far beyond, in other words, about 15 billion kilometers out there, the Oort cloud, and then you've got the Kuiper belt that's closer in, and then you've got all of the little, and what, I don't even know how many moons there are around Saturn right now. There's too many. We keep looking at them, and then all the little asteroids and just tons of stuff out there that we don't see. Okay, so I'm going to talk about the impact of impacts. Oh yeah, I have Stellarium on my phone, and I love to go out and take a look because I like to refresh myself about what we're actually seeing out there. I mean, we kind of see in two dimensions. We just see a sphere, which is why people kind of thought it was a sphere. So we don't really know that what we're, yeah, it's open source, worth getting, I agree. And we don't really know whether the star or whatever we're looking at is nearby, or in other words, the nearest by is about 4 light years, but we don't really know whether it's that close or thousands of light years. We just know it's up there and it's bright enough for us to see. So, first of all, from a timeline standpoint, we're going to be looking at the solar system and the impacts in the solar system. Note that the universe, which started some like 13.567 billion, whatever, years ago, our local galaxies, the Milky Way and Andromeda, are twice as old, 13.8, okay, are twice as old as the solar system. So the solar system is, I wouldn't call it relatively new, but certainly newer than the galaxy, so that we have had solar systems starting for some period of time. And so here's a fanciful illustration that's kind of, I like it. It's for, hi, Illing. How do you define the age of the garden? Well, that's a very good point, Dolly, because it's kind of like using some sort of thing like, hominids began on June 4th, 15 million BC or something. It means nothing. Time's an illusion. And even when you get near high gravity things like AM or PM. Wow, that funny that you mentioned that. I'm watching my time, Gus, because I want to get through some slides here. But there have been people who have said, okay, creation started at 4 p.m. on June the whatever, blah, 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 blah. And so it's like, okay, yeah, okay, okay. Does a galaxy congeal? Seeing as if you could answer some of these, it does. I don't know about congeal. It certainly changes and evolves the same way as other things. It changes over the years. because stars form, stars die out, that sort of thing. Okay, so anyway, the solar system, let's go back 4.6 billion years ago. This is what it may have looked like at that time. And at that time, and then the planets, yeah, galaxies evolve over time, so that the planets um, were the largest objects in that big ball of gas. Yeah. Oh, go ahead, sis.
Yeah, I'm sorry to interrupt, but I mean, there's an interesting question there about galaxies. Do galaxies congeal? In a manner of speaking, that does happen because when galaxies form, they form in basically groups. And the groups of galaxies, there's usually like a few giant spirals, and there are a lot of dwarf galaxies. And the galaxies sort of congeal in the sense that the giant spirals end up eating up the dwarf galaxies. So you do have evolution over time where dwarf galaxies are incorporated into larger galaxies.
Yeah, and the Milky Way is actually a barred spiral. Yes. Yeah. I sorry, I have something in my mouth. I thought the sis would say more. Okay. So anyway, before the planets got to where they are now, they were wandering around a little bit, and then now they are actually glad to have balance in there. Okay, the planets wandered around a little bit, particularly the large planets, where you have Jupiter and Saturn. I mean, Earth's gravity is so minuscule compared to the large planets um, that they tend to dominate things. So you have those rings there, which are actually the larger planets, and then you have to look inside close to the sun there to actually find the inner planets. But the idea is they wandered around a little bit and they disturbed a lot of the planetesimals and little tiny pieces of stuff and caused them to come inward towards the inner rocky worlds like the Earth, and that caused kind of havoc for the inner planets. And I'll show you what I mean, like that. So about 4.5 billion years ago, it's we we looked at moon rocks and we said, well, you know, one of the ways to explain what we see on the moon rocks is that there was a large object the size of Mars that whacked into the proto Earth, and then it the two of them were molten, and there's a good NASA supercomputer video that shows the complexity of that collision. And in any case, the core of that planetesimal that hit the proto Earth then sunk into the middle of the Earth, and so Earth has big cosmic splat. That's kind of technical, and it had then the core there sunk to create the current large core of the Earth, and then the remnants became the moon. So that was probably one of the biggest impacts that impacted both the Earth and the moon, and also in the solar system. Now, there have probably been larger events in Jupiter and the outer planets because some, since which one leans over on its side about 90 degrees? Is that Neptune or Uranus? Well, one of them kind of got whacked over, and so it's not Uranus. It's not normal to be on your side like that, spinning like a top. Thanks, Brittany. Um, so something may have whacked that, and you can see remnants on other planets of very large collisions, similar to the Earth-Moon one. Okay, so anyway, you can see that the moon's only about a tenth of the distance. That's the moon back there, and so that particular collision would have been obviously catastrophic for any life. Fortunately, there wasn't at that time. However, let's take a look at the moon first and then flip over to the Earth. Is that the moon, it's a smaller body. It doesn't have as much gravity, but objects that are going toward Earth, then if they miss Earth, they can often hit the moon instead. Um, oh, there are, and I'll get to that in just a second. Basically, since the moon has no weathering, erosion, and all that, you can see every tiny little object that's ever hit the moon. And so you can see kind of, there's no reason to believe that the Earth also had the same sorts of impacts. So let's take a look at the moon first. First of all, there's a giant impact on the moon a couple million years after it formed, and it basically formed this huge basin that's near the South Pole. And that's actually a false image of the elevation of that area. And you can see, just thousands and thousands and thousands of impacts there. A false color, yes, image. And then around, because Jupiter and Saturn and stuff had disturbed the objects in the inner solar system, there was what's called the late heavy bombardment, nearly a billion years after the formation of the solar system here. And it created a lot of what you see on the moon that looks like seas, like the Mare Tranquillis, or Sea of Tranquility, which is where the first moon landing was, that sort of thing. And then, of course, everything cooled after a while and formed all these seas that we see. And the large basins and stuff, because they are such large impacts that you have these lava beds. Now, we have had on Earth, we have also had large lava outflows. There's something called the Deccan eruption, which is India, which helped to contribute to one of the mass extinctions long time ago. And also Siberia, a large lava outflow at that time too. Okay, but pretty much the moon, the history of the moon was over, at least the large impacts was over about a billion years ago. Okay. But there were other ones, in particular, some of the largest ones we can still see, because when they went splat, they shot out material hundreds of kilometers away. And so you can get an idea that if something that large were to hit the Earth, it would shoot out materials quite a ways away. Like for the one that killed the dinosaurs, most of the dinosaurs, birds are dinosaurs, or descendants of dinosaurs, or descendants of what were at the time alive, that sort of thing. But in any case, it shot out flaming material that caught the forests on fire and all that. But then the moon doesn't have an atmosphere, so all you got was these craters and stuff that got shot out from the craters. But on the Earth, obviously, it was a much bigger deal, because you basically had a nuclear winter and firestorms all around the Earth and all that good stuff like that. Okay, does the moon still get hit? I haven't showed this one to the moon base group yet, but the fact is that they are monitoring the impacts on the moon the same way as they are on Earth, and there are hundreds of small impacts every year on the moon. Those are some of those. Those are 54 of them within a couple of year period that only show the areas that they can see. In other words, those were the areas where it was dark because of the phases of the moon, so you could see these little things that lit up. You'd see a little light going on. Now, notice that some of them, that the yellow ones are basically sporadic, and then the ones that are in white, blue, green, red are associated with meteor showers. In other words, you got the sonic wave, you've got this molten material that's got shot out long ways away, all that good stuff like that. So there's some good videos about what it might have been like at that time. Okay, so for our moon group, we were looking at, well, what is the implications of this? Well, on the moon, you can expect large objects, larger than kilometer-sized objects, to hit every 10 million years. Well, that's fine. 10 million years ago, humans weren't very evolved by then. So, in other words, that might not be an issue today. But 1 meter objects hit about every few weeks. So you wouldn't want to, and they create craters which would wipe out a moon base. So you wouldn't want to have that one. But remember that in the movies, for example, these asteroids always seem to hit cities, okay? But what percentage of the surface is a city? It's more likely that they're going to come down in the ocean, like in the movie Deep Impact. Now, what would happen? Okay, somebody can answer this. What would happen if a piece of an asteroid, a large piece, went down in the ocean? Yeah, Mike, exactly. In other words, a tsunami, right? Tsunamis or tidal waves could ripple around the whole Earth. So we saw what happened when the earthquake, for example, off of Indonesia, that tsunami went all the way to the coast of Africa and went right over the top of the Maldives and that sort of thing. So if you're talking about a tsunami that's 1,000 meters tall, now you're talking about something. In the movie Deep Impact, it hit the Atlantic off of the east coast of the United States, and the tsunami went inland and reached all the way to the Appalachian Mountains. Well, there you go, Dolly, the whole bit. In other words, you got a lot of steam. There's uh, this isn't all about what could happen, but my presentation is more like, okay, what's the probability? What have we had events like this in the past? That sort of thing. So but yes, I'm glad you guys are answering the rest of it. In other words, what could happen? Okay, so let's go to Earth. We took a look at the moon, and let's go to Earth. So the fact is the moon is still active as far as small objects hitting it. It's just that the probability of it impacting the moon base may not be high because you're talking about a point on the surface of the moon. So it's unlikely that it would actually hit on or near that spot. Particularly if you're underground, that might be. Um, well, absolutely, tagline. I'm glad you guys are thinking of this. We may have to have a presentation on what happened with the Chicxulub event because we know quite a bit about that one, the one that killed the dinosaurs. Okay, whoops. Let me go back. Okay, so anyway, in 2018, now we're talking like, lifetime of pretty much everybody here, unless you happen to be under 8. A small Apollo, I'll explain that in a minute, near-Earth asteroid, about 3 meters in diameter, entered the atmosphere in 2018 near the border of Botswana and South Africa. We know a lot about this because we've been tracking these things. And so we knew where it was going to hit and how big and the angle and all of that good stuff like that. Okay, so what is a Apollo astronaut? Well, here are the categories of near-Earth asteroids. We call them kind of near-Earth objects, but in this case, they're talking asteroids. You've got the Apollo ones, which actually cross the axis of Earth's orbit. You've got ones which are outside, called the Amors, which are between Mars and Earth. They're not in the asteroid belt necessarily. They come pretty close to Earth. And then the Attens, if I'm pronouncing it right, that also cross one of the or Earth's orbit. And then and the Ataras, if somebody knows how to pronounce it, let me know. And that's within the Earth's orbit. In other words, closer to the sun than the Earth. So there are 2, though, categories of near-Earth asteroids which could impact Earth if they happen to be crossing and happen to have the same angle of inclination, all that stuff, could actually hit Earth. So, do objects hit Earth? Well, um, if it's a meter or below, it generally tends to burn up in the atmosphere. But they are impacting the Earth all the time. Now, the fact that there is 70% water and that basically far north, far south, there aren't a lot of people to see them is a good thing. But you're still talking about maybe a quarter of the Earth that is land where these could be observed. Well, exactly, Susan. There's a couple of good videos on the one. If you look up impact event in Google, it shows what the I was going to include it on a slide, but we only have an hour here. But it shows the how it's not just an orbit going round and round. It's really complicated orbits for some of these near Earth asteroids. Okay, so a kilogram of TNT produces about 1,000,000 joules of energy. The largest ones of these ones, bolides, are essentially these tiny little things that come into the atmosphere, and some of them you'll notice are up to what is it? I could about 10,000,000 joules, and this is a period of just about 20 years here that you can see that we get the same sort of thing. Now on the moon, these would all be little craters. On the Earth, a lot of them burn up in the atmosphere, but some of them are pretty big. So if you're talking about 20,000 tons of TNT or whatever, like a nuclear bomb, none of these would do that. But have we had events like that in the past? Well, let's take a look. So in 2013, does anyone remember this one? This was a pretty celebrated little event. A 20-meter object that was now 500 kilotons is the first nuclear bomb was only 20 kilotons. Okay, so this is big. And it caused, but a meteor of that size coming into the Earth's atmosphere will cause there are, and for example, the picture on the left there is taken from somebody's camera in their vehicle. I would have liked to see that. And then the other one is a higher level one of a bolide coming into the Earth. But essentially, it was a small town in Russia, and it was bright enough. In other words, if you're outside at the time or even inside, this thing was brighter than the sun. And so people looked at it, and there was both a sonic boom, because now remember that anything that hits the Earth is going to be traveling at greater than about 30,000 kilometers per second, because essentially it has the Earth, 30 kilometers a second, excuse me, 30,000 kilometers per hour maybe. But the idea is that it has to be beyond Earth's escape gravity. Yeah. Okay, there you go. Okay, but in any case, what would an object traveling that fast in the atmosphere of about 20 meters do? Well, it causes sonic boom, for one, because it's going way, way faster than the speed of sound. It shattered windows, brought down some walls, knocked people to the ground. And this was in a small town in Russia in 2013. Yeah. So you may have read that in the paper or not, depending on what you read in the paper. Or online in this case, 2013. Oh, and then they went out, since it was snowy in February. They went out looking for it, and they found a hole in the ice in a lake, and they fished out some pieces of the meteorite in this case, because it hit the Earth. Well, we do, and pretty soon, if you guys are around long enough, the International Space Station coming down in a controlled descent should be rather spectacular. It's going to be like a big fireworks show. Okay, so how often do these? Yeah, there you go. Tagline. That's a good perspective. In other words, it's got a lot of land, but not a lot of people. Yeah. Uh, like Skylab, if you remember. Exactly, if you're old enough to remember Skylab back in the 70s. Or was it 70s that it came down? Okay, so anyway, well, that and says that's part of what I'm getting at is that there's 70% of the Earth is water. So, um, oh, good. Okay, thank you, Day. Now, if you haven't been, by the way, since free advertising here, if you haven't been to Day's uh, dinosaur museums, they're well worth going. They're up on platform above Scientia. Let's see. Okay. I'm looking at the chat. I let's see. Okay. Okay. So anyway, continuing. So how often do objects collide with Earth, and how big objects collide with Earth? Well, it's somewhat linear, and you can see that, for example, the ones that are a millionth of a meter, in other words, just a tiny little, like every billionths of a second or so, you've got the tiny little ones. If they're a millimeter in diameter, in other words, like a sand grain, we've got those hitting Earth about every 30 seconds. And it actually adds up to tons a year, believe it or not. And then you've got meter-sized ones coming somewhere on Earth about every year, 100-meter ones, which are quite sizable. Remember the one in Russia, there was only 20 meters. Every 10,000 years, and then the real dangerous ones are the ones which might. What? Ooh, hey, good calculation. Okay, so anyway, if you have one that are like a meter, that's not going to cause a big deal. That's basically you're not even going to see it because maybe just like a shooting star. On the moon, it would be different. If you have a 20-meter object like the one we were talking about earlier, that's a local event where it might blow out windows, and depending on, if it hit in the middle of the city, it'd be a big deal. Now, speaking of cities, every 10,000 years, you can expect an object about 100 meters, which is large, to basically, if it actually hit a city, which of course the probability is small because that's not a large percentage of the Earth. Even the largest cities are not a large percentage of the land surface. It would wipe out that city or cause an enormous tsunami, which would probably go around the world. Now, the big ones, the kilometer size ones, we're going to be talking about some of those here in a second. Those are the ones that fortunately you don't see very often, and they're the ones that cause regional issues like wiping out Europe or part of North America or North Africa or things like that. And then the other ones are global impacts. We'll take a look. Okay, so now does anyone, yeah, massive. Okay, so now I'm sure there's nobody in here that's actually remembered this one because that's about when my grandmother was born. But this is within the last 100 or so years. This is actually the largest impact event in recorded history. That was fortunately, yeah, that was a, yeah, there you go. Was a Fortunately, this is like in Siberia, and they went out there and they go, oh my goodness, because there's trees that were just absolutely blown down for miles around or kilometers around. This one, there's no crater because it exploded 6 to 10 kilometers above the surface. But it did, yeah, millions of trees. It did shatter windows hundreds of kilometers away. And it was, so this is 50 to 80 meter size, which would have been 10 to 15 megatons, which is larger than any nuclear device that has been exploded. Yeah. Ram pressure, good term there. If you go out to Arizona, you can see this one, which has not been weathered much, and that's part of the reason why it's still there. But about 50,000 years ago, this is a grassland with mammoths and ground sloths and stuff, and this is about 10 megatons that would have definitely wiped out the largest city if there had been cities during the mammoth days, that sort of thing. Okay, so how many now? Now let's get down to Earth, so to speak. Okay, so near Earth asteroids. About 25 years ago, we started looking seriously at since there were Hollywood events or whatever, is we were looking at there was a satellite that went up in the late 2000s called the WISE, and then it was purposed to look for near Earth objects, NEO, in 2023, and it said, wow, there's lots of them all over the place. And then this is how many that they found so far, like 30 something thousand of these things. Now notice, well, no, these are not man-made. These are natural objects, 30,000 whatever, that are near enough to Earth that they're an issue. Notice that the ones in orange over on the left, the ones in orange are 100. I don't know why it says 140 meters. It must be the device itself that has these thresholds. But in other words, those are greater than 140 meters. That's big. Remember the ones we've been looking at so far that did that. Like the one that did the in Russia, the Chelyabinsk one is basically, these are larger than that. But notice how few objects there are that say are 1,000 meters. In other words, a kilometer. Now, when I say few, that's compared to the other ones. In other words, 800 of ones that if they hit Earth would cause a major issue. That's quite a few still wandering around out there in space. Good gracious. But at least we know. Okay. So now somebody might ask, anybody want to ask? Okay. Are we tracking these? And the answer is yes, there. If you want to look up that link, it's a fairly easy link at neo.ssa.esa, European Space Agency.int, risk list. And what they have on the risk list is they have all of the objects. They're tracking a couple thousand of them, objects that they have a good idea of where they are, what the probability of impact and stuff. So let me just walk you through here real quick. Notice that the second object down on the bottom there says there is a potential for it hitting the Earth. This is by risk. So you got number one, number two. The one there, 2027 on May 1st. It's about 25 to 50 meters in diameter. That's a big chunk of rock. But fortunately, for all of the scenarios, the probability of it hitting Earth is only 1 in 6,200. And so basically, and also that TS, the one, the little circle in there where it says 0000, that's what's called the Torino scale, which is the scale for impact on Earth. If you have a Torino 10, forget it. That's, like extinction level. But if you have a Torino 0, that's not going to cause a big deal. In other words, if you look at this in total, you'll see. Now, notice up on the top, though, there is a special risk category. That's an asteroid called Bennu. You may know that if you're a buff on this sort of thing. If you really like it, that one or space buff, that may have a special meaning to you because, and I'll show you the next one, but notice how big it is. You're talking about 480 meters in diameter, and there's not a high probability, but if it would hit Earth, it's in 2182. In other words, it's beyond 100 years or so for us. Nobody here will be around, or? Well, that's a good. That's a good question, and let me see if I can answer that. I may need to go back a slide or so to do that. Let me go ahead for a moment, but hang on to that question. In other words, what's the minimum impact index, or what size in order to completely destroy it? Now, when we say completely destroy Earth, we might have to refine that definition, because even a Mars-sized object didn't completely destroy Earth. It turned Earth into a molten blob. Um, but when you say completely destroy Earth, are you talking about completely destroy all life on Earth? Or are you talking about completely destroying a city? That sort of thing. If you're talking about extinction level, yeah, all life, okay. Well, let's take a look, because I will show you some of the ones that have impacted Earth and how big they are, okay? And so that'll probably answer the question. Well, there you go, Dolly. In other words, on the event that wiped out most of the dinosaurs, everything under about 5 kilograms in weight survived. So mammals who could hide in the earth survived. Birds who could fly away survived. Um, Animals in the sea, there are quite a bit of marine species that got wiped out, but obviously amphibians like crocodiles and frogs and everybody. Okay, yeah, that's kind of wide the scale, and of course bacteria, all of those sorts of things survived. So in other words, it didn't wipe out everything, but it sure did a number on a lot of stuff. Thanks, says for the link. Okay, so what do these look like, and how do we know this isn't just a good telescope? We actually had probes go out to these objects. There's Bennu. Bennu is a 1/2 kilometer wide Apollo asteroid that goes by Earth every 6 years. So it has a probability of impacting Earth in the year 2182. But there's not a high probability unless somebody perturbs its orbit. You'll notice these aren't pretty objects because they don't have a lot of gravity. Well, yeah, cockroaches will survive anything, and tardigrades. Okay, but notice just because we monitor the near Earth orbits, well, actually, do you know if humans were wiped out, most cockroaches would be wiped out also, because cockroaches depend on humans to live. But as far as a cockroach goes, they're pretty impervious to a lot of stuff. Okay, so now notice just because we monitor the near Earth objects does not mean that some comet couldn't come looping into Cancer. Right. They have 9 lives. Okay, so comets also could, just next year, some big comet could come looping into the, or not impacts, right, into the inner part of the solar system, would probably detect it out near Jupiter or someplace and would go, oh my goodness, it's going to hit Earth. And so we wouldn't have a lot of time to worry about if a comet hit the Earth, which would be almost the same. In other words, the Tunguska one back in 1908 could have been a comet because it blew up in the atmosphere up high, rather than a carboniferous, a chondrite, whatever asteroid, a more solid one, iron meteor, that sort of thing. Okay, yeah, they have a lot of dents. Why do they have a lot of dents? Anybody answer? Because? Yeah, no, not erosion, impacts. That's right, tiny objects that mash these things. Bad driving. Wow, that's probably the other reason. Could be on the comet. There could be outgassing craters. I mean, there's all kinds of stuff. But basically, little things whack into other things, etc., etc. Okay, so now let's take a look at the Earth specifically. I got about 15 minutes. Is back in the problem with having a object whack into the Earth is the Earth will survive and there'll be big craters, but the problem is life is kind of tenuous and you have a very thin atmosphere, and so it depends on when and how big the object is that whacked into the Earth. In the very beginning, there, even within the first 500 million years, you have the oceans forming. You've got um, magnetic fields. You've got lots of other stuff going on, even within the first 500 million years. If you add another couple billion years out to about 2.5 billion, now you've got all of the early cells, and you've got the macroscopic objects like stromatolites, which are essentially red-green bacteria and other stuff that are forming. And if you had, depending on where it whacked, you could have wiped out life in its beginning. It could have impacted the atmosphere and changed the atmosphere and the temperatures and all kinds of stuff like that. Okay, so this is back in that time period where the stromatolites started. So it all depends on. Oh, thank you, Tag. Okay, it all depends on when it might have hit Earth as to what it could have done to the evolution of life. Now, by the way, this is another great. It's an interactive. Oh, you know what I didn't do? Darn it! I didn't change this slide. What this slide is this is a dynamic view of just a tiny bit of the Earth's surface that shows the known craters there. And some of these craters date back 370, yeah, it does, 5 million years ago. There's a couple that are within the last million years. That red object is within the last million years. Some of those bigger impacts there, the ones with the larger circles. There, you didn't want to hear me sneeze. Okay, so some of those bigger circles there mean larger impacts, up to, in this case, 10 meters or so, 10 kilometers in size. But some of those are like 375 million years ago. Well, the problem with the 375 million years ago is that there were two that were 10 kilometer size asteroids that may have been a factor in the late Devonian extinction, the one basically that marked the difference between the age of fishes and the age of amphibians. But this is well before the dinosaur time period. But basically, you're talking about the time period when life first started on Earth to come up from the seas onto Earth. If you'd hit it at the wrong time, you could have had a real problem with the evolution of life. Now we know that 66 million years ago, Central America, this is the one that hit off what's called the Yucatan Peninsula, was also a 10-kilometer asteroid, and it basically was the cause of the mass extinction, the last big mass extinction, not the one that we're causing right now, but the one that's between the Mesozoic and Cenozoic, or what's called the KT boundary, that wiped out most of the dinosaurs. Now, there was also, since then, there have been other minor extinctions, so to speak. 34 million years ago, there was a event that may be related. This is straight out of Google or Wikipedia. Is that related to impact of more than one large body, Siberia, and what's now Chesapeake Bay? Yeah, now that's interesting. Yeah, there you go. Now we're starting to throw up some information there for people that study this stuff. Yeah, a stranger, for example, as early as 12,500 years ago. Now, you know, it's interesting that, and I think I'm running toward the end of the slides here, but unless I added a couple more, which I may have forgotten to do. Well, exactly, Tag. That was fairly recent in in terms of in terms of the entire history of the solar system. And Stranger, for example, yes, we know that there have been impacts even more recent. There's one on Greenland, for example. There's one under the ice in Greenland that we found. There's other ones like that. And there are also events, volcanic events. For example, about 12,500 years ago, the Native Americans in Northern California or Southern Oregon talk about two volcano gods, for example, Mount Shasta and what we now know as Crater Lake, fighting. And then one blew its top, which is Crater Lake, and they actually have legends from that time period. And there may also be legends of things that happened as a result of impacts within actually historic time periods. Yeah, I'm only, because of the time, I'm only looking at just a sampling of known impacts. A lot of volcano eruptions are part of it, but it could be just like anything. When I was studying, well, when I studied airplane accidents and other stuff when I was in the Navy, one of the first things they told us is that you rarely have an accident, whether it's a car accident or a plane accident, without more than one causal effect. So, in other words, it may be okay, the person is looking at their phone and then the light goes on, or the person in front stops to turn, or, it's the same thing with the extinctions. Even the one with the dinosaurs are saying, okay, the meteor that hit 66 million years ago may simply have been the last straw, so to speak. In other words, the dinosaurs were already having a problem because of climate change, because of volcanoes, because of any number of things. And then the asteroid hit, and it's like, okay, coup de grace, that sort of thing. Coup de grace. Well, tagline that was actually Greenland. It's called the Hiawatha event. I don't know why it's called Hiawatha, but it's actually under the ice in Greenland. You can look it up. Okay. Interesting historical note. Oh, okay. Now, Day, you just came up with something. Is at some point here we may have to talk about the how do you pronounce it? The Milankovitch cycles, the ones that are 100 to 110 thousand years, 40,000, 26,000. There are cycles based on the Earth's inclination and orbit and a bunch of other stuff like that that help to, let's see, okay, look at stuff that you guys are doing. Do the impacts ever cause volcanic? Well, Dolly, that was what I was kind of talking about it, because there was a mention of the event about 12,500 years ago. And then if you have events like that, which rattle the Earth's cage, so to speak, you may very well set off, if not earthquakes, volcanic eruptions, and all that stuff like that. So a confluence of events, Dolly says. Okay. And yeah, oscillations of the Earth. Okay, that's what I was talking about. Okay. Precession, all of that stuff. Okay, so let me go. Okay, so I'm not sure if this is my last slide or not. Okay, so the idea is that, and this comes back to what, because I forgot to add a couple slides. Okay, so this comes back to this one. What would actually happen if we have an event? We've talked about it. And in the movies, there are some like 2012, which is pure science fiction because there's no way that you'd have the floods go up to the top of Mount Everest or something. But for movies like Deep Impact, where there are some of the things that you've mentioned that they didn't show in that movie. So, for example, the shockwave, which they actually did show in the Don't Look Up. They showed a little bit of the shockwave thing. There would be the tsunamis for sure, but there would also be material that is sprayed out. That's first of all, the meteorite itself would become molten, that whole area there, and then it would spew stuff all the way out, just like a huge bomb would spew stuff all the way out for miles and miles of a volcano for hundreds of kilometers, and catch the forests on fire and lots of different types of stuff that would happen. Yeah, hope survives. Okay. So, anybody want to add anything? I'd like to go right up to the second here and use them, but I forgot to add a couple of slides, so I'm 5 minutes early. So what's the likelihood of something like this happening in our okay. So what's the bottom line? The bottom line to me, and you guys can add your own comments. Very impactful. Thanks. I knew you'd come into witticism there. Thanks, Ted. Okay, so in any case, what is the likelihood of something like this happening? Not very high. We're more likely to wipe ourselves out from nuclear weapons than we are from some asteroid impact. Pretty low. I'm not sure, Nero, but I suspect it's pretty low. Now, when you say something, I'm not sure, but an asteroid, definitely extremely low. Oh, yeah, okay. So, but in other words, we have a lot more to worry about right now than we do objects smacking into us. Historically, there have actually been, in the 1950s, there was an asteroid that came, not an asteroid, but a tiny object that came through the roof of a lady's bedroom and hit her in the thigh, and it caused a big bruise. That, of course, is not, yeah, I know, it's not a likely thing to happen. That's kind of a 1 in a billion chance. Of course, it's, billions of people, but, but yeah, I think we're more likely to start some nuclear conflict, which, is reassuring. Okay, but remember that if the impact of a nuclear explosion, a large one, and a asteroid are not too dissimilar. That's the whole idea. When we started finding that, for example, that the asteroid off of Yucatan Peninsula, what it actually did, that was back in, we're talking about in the 1970s, that was when people go, oh my goodness, a large nuclear explosion could cause the same thing that large, that an asteroid could, namely a nuclear winter, where essentially you're talking about messing up the atmosphere with high altitude dust that then causes the temperature to drop, plus fall out within a limited area and then spread over a good area. But the big thing was the dust in the atmosphere that then cools the temperature down to, and we've seen this in earlier times, early 1800s, when you had what was it, Krakatoa or some other ones go off, and then it actually snowed in Europe during the summer because it had lowered the temperature. Yeah, blocks photosynthesis. So all you'd have to do would be to have either a nuclear bomb, a lot of them, or a big asteroid, and what you do is you blocks photosynthesis. Of course, once plants die, animals die, everybody dies. End of story, except for the ones that are able to survive for a period of time. Yeah. So, okay, Nero, what I would recommend is we don't spend our time trying to save us. We spend our time trying to save everybody, the whole planet sort of thing. Yeah, the doomsday clock. Okay, so I'm gonna stop talking. This is the end of the presentation. We're now at the hour.